Welcome back to the video. Today we're going to be creating a Turing machine for this language right here. A to the n, and then b 3 to the n plus 2. And then n has to be greater or equal to 0. So the way I like to do this, I actually like to write the actual string, and then we'll give a random number to n. So when it says a to the n, we're going to have two a's, and then b to the 3n plus 2. 3 times n is going to be 2 in this case, plus 2 is going to be 8. So we're going to have 8 b's. That's 5, 6, 7, 8. And as we did last time, I like matching. For every A, we're going to match a B. A, B, and we're going to have this many B's left over. That's going to be a lot of B's left over, but that might be the algorithm. For every A, match a B. Let's do a different number for n. N equals 1. And if that's the algorithm, we should have this many B's left over. So we're going to do A to the 1 is going to be A. 3 times n is going to be 3 plus 2 is going to be 5 B's. Do 5 B's. So for every A, we match the B. And then we have 6 B's left over, and then 4 B's left over here. So it's not going to be the algorithm. In this case, I know what it is, but if you don't, just like guess and check. So we just guessed for every A, we cross out a B. That wasn't the case. What if we do A? For every A, we cross out 2 B's. And then we have 4 B's left over. So let's do where n equals 1 again. A to the 1 is just A, just 1A. 3 times 1 is 3 plus 2, then we're going to have 5 B's. I'm just checking where n equals 1, and this is where n equals 2. That's all I'm doing, trying to find a pattern. If we cross out 2 B's, we might have 4 B's left over. So for every A, we cross out 2 B's. In this case, it's not the same thing. We have 3 B's left over. So let's do it where we cross out for every A, we cross out 3 B's. A right here, 3 B's, A right here, and then 3 B's, 2 B's left over. Now let's do it again where A equals 1. A, cross out 3 B's, 2 B's left over. In that case, that works. Let's do where n equals 3. There's going to be a lot of B's, I know it. We're going to have 3 A's. 3 times 3 is going to be 9, plus 2 is going to be 11. So we're going to have 11 B's. I like to write them in sets of 5. And then one extra one. So we should have 2 B's left over if this is going to be like the correct algorithm. For every A, we cross out 3 B's. A, 3 B's, A, 2, 3 B's, and then 3 B's, and then we have 2 B's left over. So that's going to be like the correct pattern and the correct algorithm. I like to write the algo description up here. You could say for every A, cross out 3 B's and 2 B's left over. And then I like to highlight it just so I know what I'm doing. Well, that's going to be the algorithm. If you don't can't find a pattern, just keep writing numbers for n, and then just look for a pattern, and then eventually you'll find one. And then we can write the actual algorithm. It's going to be very similar to my last video. So we're going to be replacing all the A's with X's, and then all the B's with Y's, and then we're going to match X to Y's. And then at the end, once there's nothing to the right of an X, we're going to bypass all the Y's, and then we're going to check if there's 2 B's left over. So let's actually do a string for that so we can actually see it. We'll do n equals 3 because that's a pretty big string. It's going to be A, and this one had 11 B's. Okay, this is the case when n equals 3. All I did was plug in 3 for n. So A to the n, 3, which is 3, so 3 A's. And then B to the n, B to the 3n plus 2. So it's going to be 3 times n, which is going to be 3. 3 times 3 is 9 plus 2. So we get the 11 B's. That's all I'm doing. Now I'm going to write the algorithm to be sure there's only 2 B's at the end. So if there's only 2 B's at the end, that means this string is going to be accepted. Okay. So we're going to read an A. And then we're going to write an X. And then move right. In my last video, I kind of explained this is going to be A, arrow, X, R. This is read. So when I say we're going to read an A, This is right. And this is the direction we're going to move. That's the notation we use in my class, so I'm just going to roll with that. I know I've seen in other videos on YouTube where you do like a slash or whatever, but that's going to be the notation we're going to be using for this Turing machine. So read an A, write an X, and move right. I'm actually going to like show you like the algorithm like that we're making like live pretty much. So we're going to read an A, write an X, and then the head is right here above another A. So we want to bypass all A's. We want to like move past the A's into a B. The only thing with that, once we're like on the next like iteration of this algorithm, there might be a Y right here because we are going to change B's to Y's. So we're going to bypass all A's and Y's. And then you'll kind of see as we go through along the string until we hit a B. So in this case, there's only A's. So we're going to move past this A, move past this A into a B. So now we have a B. We have to tell the Turing machine what to do. So we're going to read a B. By the way, I put them in quotation marks so I don't get confused with this A and this B. Whatever's in quotation marks is what we're actually going to be doing the operation on. And then we're going to write a Y. I chose X. I chose A to correspond to X and then B correspond to Y. You could literally choose whatever. And then you're going to move right. So far, so we're going to replace this with Y and then move right. So far, we're matching every A to a B, but that's not what we wanted. We want to match every A to 3 B's. So we could copy and paste this 3 times pretty much, if it lets me. Okay. So that means we're matching every A to 2 B's, but we wanted 3 B's. And then we're going to alter this a little bit. So instead of moving to the right, we move to the left. Okay, so now we're right here at this step. So we read a B right here. We changed it with the Y. So now we're right here. It's telling us to read a B, write a Y, move to the right. Now we're above this B. Read a B, write a Y, move to the left. Now we're right here, but it's telling us to move left. So now we're sitting above that Y. But we want to make this kind of loop. So we could say go all the way back until an X. So on the way back, we're going to pass, in this case, Y's. We're sitting above a Y, and then A's. So we could say bypass all A's and Y's. It's pretty much the same thing as up here. But in this case, we haven't seen a Y yet. Now we will, but we're going to pass all the A's and Y's and then go left. So let's actually run it through. We're above this Y. We're going to pass this Y, pass this A, until we hit this X. Once we hit this X, we're going to go right. I'm not going to write in the actual algorithm, but that's what we're going to do. We're going to go right, and that's going to start the loop again. So we're going to write an X, Y, Y, and then Y, X, Y, Y, and then Y, and then 2 B's left over. So pretend we're right here. We already read an A for 3 B's. And then we're going to read an A, write an X, move to the right. So we're sitting right here. But there's no A's. So we can't move to the right. Oh no, we're sitting right here, I'm sorry. We're sitting right there because we're reading we're gonna bypass everything into an X. Once we hit an X, you're gonna move to the right. But there should normally there would be an A up here. That's how the algorithm, that's how we defined it. But we could do another condition where instead of there being an A, we could see read a Y. Or read all Y's. So this is gonna bypass all the Y's we already did. And then it's gonna put us above the B. If there's any B's left over, then it's gonna be accepted. Only if there's 2 B's. Read a Y until a B. And then 2 B's, accept. This seems really complicated, but once we make the actual Turing machine and then go through the string like step by step, you'll kind of understand it. For me, the only way I got better at Turing machines is by actually designing Turing machines. This is kind of like a how to like understand them, but you actually got to like do some yourself. You won't get better just by watching this video. You'll understand them, but actually like going through the problem solving process is how you're gonna get better. It's gonna be our first state Q0. So we're gonna follow the algorithm. We're gonna be right here. Read an A. Read an A. Write an X. Move right. Read an A. Write an X. Move right. Wrote an X right here. We're above this A. And the next thing we said is bypass all A's and Y's until a B. So it's going to be our next state. Looks a little sloppy. Call that Q1. The way we could bypass everything is we could self loop. The way we like bypass an A or like a letter and not write anything, we'd say read an A, write an A, and then move to the right. So we're just reading that letter and then writing it back and not changing anything and then going right. And then we want to read all A's and then Y's. Read a Y, move to the sloppy arrow, move to the right. No, read a Y, write a Y, move to the right. So we're going to read all A's. You read this A, read this A. Now we're sitting above this B. So now we wrote read a B, we're right here. Get rid of this arrow. Read a B, read a Y, move to the right. Read a B, write a Y, move to the right. Write a Y, and now we're sitting right there. And then we'll call that Q2. I'm literally just following the algorithm step for step. And then we're right here. Read a B, write a Y, move to the right. Read a B, write a Y, move to the right. Once you get your algorithm down and it's good, like creating the machine's not hard. And once you start doing a lot of Turing machines, you'll see like a lot of the algorithms are pretty similar. They start off pretty similar. And then so far we read two B's. Now we're gonna read the last one. Read a B, write a Y. In this case, we're moving to the left. Let me actually write it. So read a B, write a B, move to the right. We're here. Read a B, write a B, move to the right. We're here. Read a B, write a Y, move to the left. So now we're sitting here again. And then we'll make this another state. We'll call this Q4. Okay. So we got this 3 done. So now we're going to go all the way back into an X. So we can go all the way back to Q0 on an X. So we could say read an X, write an X, move to the right. But for us to go all the way back, we have to bypass all the Y's and A's all the way because we're still right here. So the way we could do that, we could do another self loop. So we're sitting above a Y. There's little arrows where the head's at. We could read a Y, write a Y, move to the left. We kind of wrote it here, but we wrote where to go. So we're just at that part right there. And then we're also going to pass A's on the way. So read an A, write an A, move to the left. So we're going to pass this Y right here, move to the left. A right here, move to the left. A here, move to the left, until we hit an X. So we're right here. If we hit an X, we're gonna move to the right, and it's kind of gonna loop. So we're gonna read an A, just stay right here, write an X. And now we're at Q1. Bypass all the A's, A, and the Y's, Y, 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 and now we're right here. We're sitting above a B. So it's telling us read a B, write a Y, move to the right, move your head over to the right, right there. This point, write a Y, move to the right. Right here, we're going to write a Y, but move our head over to the left. Now we're at Q4 right here. So we're going to bypass all the Y's and A's until we hit an X. Y, 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 Y. We keep moving left. A, move to the left until we hit an X. Once we hit an X, we're right here. Write an X, read an X, write an X, move to the right. So now we're above this A, now it's going to loop again. So we're back to Q0, read an A, write an X, move to the right. We're sitting above that Y. Q1, we're hitting this step right here. Read all the A's, move to the right. Read all the Y's, move to the right. Y, 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 move to the right. Now we're above this B. So read a B, write a B, move to the right. This step, we just did that one, move to this one. Y, move to the right. Now our head's right here. No, it's right here. Read a B, write a Y, move to the left. So we're going to write a Y right there and move to the left. Now we're sitting at Q4 again. Read all the Y's, move to the left. Read all the A's, move to the left. So I'm just going to move over all these Y's to the left. So there's really no A's. So we're right here now. Read an X, write an X, move to the right. If we move to the right, normally there would be an A. But in this case, there's no A. That's why we did this condition up here. If there's no more A's to be done, now we just gotta bypass all the Y's. So now we're right here above the blue highlight. Read all Y's into a B, and if there's two B's left, accept. So we're sitting at Q0 right here. Normally there would be an A to the right of the X, but to the right of the X is a Y. So we're gonna count that for in our machine. So you say read a Y, write a Y, move to the right. All that's saying is we want to read a Y, not change it, but we just want to move over. And now we're going to be at Q5. So our little arrow, our head is above this, the second Y. We want to get rid of, not get rid of, we want to bypass all the Y's. So we can do a self loop, read a Y, write a Y, and move to the right. So this is going to move the head, Y, Y, Y. So now we're right there because we bypassed all the Y's. And then what we could say is, once we hit read a B, write a B, move to the right. Oh, so we found a B. We're above this B right there. Move to the right. See if I can make this look a little neater. I feel like if you make your work neat, you'll do better. I don't know why. Okay. So we read one B, remember? But our algorithm says we have to have two B's left over. So we could literally read another B. This circle's looking weird. It's a little better. Read a B, write a B, and then move to the right. So now our head is right here, above that last B. See, I can't make a circle. Well, no, that's terrible. We'll go with that, and we'll call this Q7. Let me see if I can zoom out so you can see the whole machine. So now we read two B's, like, which should be done. Nothing like to the right of this B should be a character. In this case, it should only be like empty or blanks to the right of it. So in my class, we call this blank, read a blank, write a blank, and then move to the right. And if there's only blanks to the right, if there's a blank to the right, like the string is, that's it, the string is done. But you always have to check, what if n equals 0? So if n equals 0, we're going to have a to the n, which is going to be 0 a's, and 3 to the n, 3 times n. 3 times 0 is going to be 0, but we have that plus 2. So if n is 0, there could be 2 b's. So we have to take that into account. So we could have a state right there. We could say read a B, write a B, and then move to the right. And then we could have another one. We'll call this Q8. Read a B, write a B, and then move to the right. And then we're going to go to Q7, and then if there's like nothing there, that means it's still accepted. So if the string is just B's, we're not going to read any A's or any Y's. We're just going to read a B, which is this one right here. Head is right there. Read another B. Head is right there. And there's nothing to it. Nothing to the right of it. It just gets accepted. And this should be our Turing machine right here. Once you like actually write the algorithm, it's actually pretty, I won't say easy to actually make the Turing machine, but that should be it. The hardest part is like guessing, checking to find a pattern. But yeah, if this helped in any way, please leave a like and subscribe.